Okay, question number D. So question number C we had already seen in the previous video. Now let us continue with this one. So as a result of the ball striking the spike, what happened? So you had the ball over here and this went and it struck the spike, and as a result of it the spike went inside like this, the wall. Okay, the spike is driven a distance of 7.3 in 10 power minus 2 meters into the wall. So as a result of it, what happened? The spike went like this over here. This is the wall, so it went inside like this over here. So a ball along with the spike went like this over here. Assuming it to be a constant, calculate the frictional force between the spike and the wall. What is the value of it? That's what is the question. Now towards it, we know there is some work done by the nail because there is an energy given here, right? The energy given here made the nail to drive work because there is a displacement. The work done by the nail is nothing but force multiplied by 7.3 into 10 to the power of minus 2, which is also nothing but the work done against friction. Okay, the frictional force was there, which is F here, and it did this work against this. This should be equal to the energy present in the system. What is the energy present in the system? This should be equal to half m1 plus m2 into the common velocity square. The common velocity square. What was this value? We already found out that this common velocity square, half m1 plus m2 into v square, where is it? This is the kinetic energy final, which was 4.3 into 4.6 into half square, which is 45.5 joules. This was the value, right? 45.5 joules was the value. So your value of F should be 45.5 divided by 7.3 into 10 to the power of minus 2. When you use this value, let me use a calculator. Where is it? Right. Okay, so I will use this calculator to find what is this value. This value comes out to be 45.5 divided by 7.3 will give me 6.23 into 10 power 2, which should now be equal to 6.23 into 10 square, which is equal to around 623 unit is Newton, and since it is two significant figures, this should be equal to 620 newtons. Okay, so we have got this also. Next, we already crossed the time. Okay, 3 minutes late we are. Now let us do this one here. The next question, E. Now what does it say? It tells you the machine that is used to raise the ball has a useful power output of 18 watt. Okay, output power is equal to 18 watt. What is this power actually here? See, you had to raise this ball from here. The ball was actually here. You raise this ball upwards. So it is 18 watts. 18 watts. This has already been given. And then calculate how long it takes for the machine to raise the ball through a height of 1.6 meters. How much time do you need to take this ball from here and to lift it and keep it over here? That's the question over here. So what is the time required? Time required. Now, if you want to raise from here to here, a ball which is stationary, you want to take it from here to put it over here, you need to do work against gravity, right? So what is the work done here? It's nothing but your potential energy, mgh. So therefore, I can now write power is equal to mgh divided by time taken, because power is already given. So you find out the value of t, which should be mgh by power. What is m here? What is m here? Only the mass of the ball. Mass of the ball was 3.5 kg multiplied by 9.8 multiplied by h 1.6 divided by power. What is power? 18. Now let me use my calculator. Let me scroll this up, otherwise you will not be able to see. Okay, so now 3.5 multiplied by 9.8 divided by 1. Sorry, divided by 18. Just a minute, let me redo it. 3.5 star 9.8 star 1.6 is equal to so much divided by 18 will give me 3 seconds. So answer should be 3.04 seconds, which is 3.04 seconds or 3 seconds over here. So the answer is right, 3.6. 3 seconds or around 3.1 seconds. So thus we are able to complete all the problems related to today's problem, right? So tomorrow we will see with a new set of problems. Thank you.